So how do you multiply polynomials? Kind of works the way you think it would, right? When you are multiplying a binomial with a binomial, we have a whole thing called FOILing. But really, it's just multiplying each term by each term. So the best way when I do a binomial by a trinomial, the way I think about it is I take one of the terms of the binomial, multiply it in, take the other term of the binomial, multiply it into everything, and then you'll combine all the terms at the end. They're going to call that using the distributive property. They took the 2m and the 5 and separately are multiplying it into that trinomial. You're seeing that happen on the third step there. Then they're grouping like terms, and then they're combining the like terms. So that's it. For example 2, where you've got 3 binomials, basically you're just going to pick 2, multiply them together. It doesn't matter which 2, because remember multiplication is commutative. Once you have 2 of them multiplied together, in most cases, unless it's a difference of squares, which these are not, you're going to end up with a trinomial that you'll then multiply the other binomial by, and it'll look like part A here. So looking at their solution, they chose the first 2 binomials, multiplied them together, they combined the like terms, they ended up with a trinomial there. Then they're going to do, well, I actually find it easier to distribute the binomial into the trinomial. They're actually distributing the trinomial into the binomial. It doesn't matter. I just probably would have written it a slightly different way. The end result would be the same though. You group the like terms, you combine the like terms, and then that's what you end up with. So what you're actually ending up with here is a 6th degree polynomial because of the 3 and the 3. 2 examples like the 2 we've just done. So why don't you pause, try them, and then we'll compare answers. All right, looking at part A, I multiplied them together. 6n squared times the trinomial is that line. -7 times that trinomial is that line. The way that I like to group is I stack the parts of my product together, and the like terms are stacked on top of each other. In this case, the only 2 like terms were the quadratic terms, and I ended up with 6n to the 4th plus 6n cubed plus 11n squared minus 7n minus 21. For the part B, I multiplied the 2 trinomials together, the 2 binomials together first, and I got that 4-term polynomial. Then I distributed the binomial to the 4-term instead of the other way around. Ended up with all of those terms. When I combined them, there really was no combining, actually, because there was no like terms. I just put them in order by degree, descending degree. All right, so that would be your answer there. All right, let's take a look at moving on to example 3.